Okay, everybody, welcome to. Oh boy, can't see all that. All right, welcome to what could be the last video of the year. All right, so we're gonna move it back so we can see all of it. Oh, we still can't see all of it. Dang it. All right. So this is what we're looking at. Okay, we're going to look at a few problems that people asked about to make sure we all understand. This all involves conditional probability, which is on the last few pages. And this is going to start with page 10, numbers 11 and 12, where they give you a chart dealing with red berries and no berries. Okay, and then it says, a biologist surveyed one type of plant growing in a wooden acre, uses results shown in the table below for exercises 11 and 12. Now, the one thing I want to focus on in the bottom right, it's 100 total. That makes it easier for us because that gives us all the probabilities out of 100. All right, so it's going to be a lot easier to deal with percent. Okay, so it says, what is the probability that has red berries given that it is lob leaves? Okay, so it's the probability of red berries given that it's lob leaves. Now, the formula is always the probability of the first and the second over the probability of the second, always. Okay? So it says, what is the problem with the red berries? You go back to the chart. Okay? And red berries is 60 total because it has, all right? There's 60 that have red berries. You do that by going across. How many of them have lob leaves since we're working with that? Well, for that, we're going to go down in the first column. 12 plus 40 is 52. And then because we need the probability of both, we need to figure out how many have both, and that's 12 in the upper left. So when it says the probability of red, given that it's lob leaves, that's the probability of R and L over the probability of L. Now we're just going to plug in the numbers, R and L, because it's out of 100. If not, then you got to calculate it. So R and L is 12. So we plug that in up top. L is 52, so it's just 12 out of 52, and you answer it any way you want. Okay, if they want it as a decimal, if they want it as a fraction, they want it as a percent. Remember, if you are going to write it as a fraction, write it in lowest terms. Now, number 12 says, what is the probability it has lob leaves given that it has red berries? This is not the same thing. So it's L given R. Notice how they're different. L given R is L and R once again. So that's going to be the same, but instead of the probability of L, it's the probability of R. L and R is still 12, but this time the total that have red is 60. So we're going to do 12 out of 60, which is 1/5. Or 0.2 or 20%, again, depending upon what they ask you. Now, the next one the remaining ones we're going to work with involve, all right, oh shoot. All right. I'm just going to put that down here for a second. I'm going to move this down so we can definitely see it. All right. It's going to be easier. All right, and then we're going to move it up so everybody can see. All right, so this is on page 11, number 1 and 2. It deals with swimming. And it says that a recent swim meet, half of the swim club members experienced an improvement in their race times over a previous swim meet. The probability of a swim club member experiencing an improvement in their race time and training the week before the meet was 30%. So for the rest of the problem, we're going to go with 100 swimmers. Why? Because it's a lot easier to do percent that way. So that means half of them improved, so 50 improved. That means 50 did not improve. You just subtract. Then it says 30%, okay? Trained the week before and experienced an improvement. So 30 is trained and improved. And then in number 1, they ask, what is the probability that a swimmer trained the week before the meet given that his or her race time improved? All right, so we want to know the probability that they trained given that they improved. So again, it's the probability of both happening, the and, over the probability of the second one, which is I. Okay, so trained and improved is the 30. All right, so that's 30 over the probability that improved. That's the 50. 30 over 50 is 0.6. And you write it the way they want. Number 2 throws in more information. It says the probability that a swimmer did not experience an improvement in his or her race times and trained the week before the meet was 10%. So that means 10 out of 100, so 10, no improvement, even though that they trained. Then they ask, what's the probability that they trained given that they did not improve? So that, once again, is the probability that they trained and did not improve over the probability they did not improve. We go back to the numbers. That's an and. How many trained and did not improve? That's the 10. How many did not improve total? We go back to here, which is 50. 10 over 50 is 0.2. Okay? The last one I want to go over is on the bottom of that page. It involves a tree diagram. Okay? If you want to use tree diagrams to sort out your stuff, that's perfectly fine by me. All right? So we're looking at numbers 6 and 7. All right? It says, use the tree diagram shows the percentages of plants that receive sunlight and whether or not they grew. All right, so again, I'm going to use 100. So for the rest of the problem, I'm going to say there was 100 plants. All right, now if you look at the tree diagram, it says 35% got sun. So that means 35 out of the 100 got sun. 65% got no sun, so 65. And it then says 80% of the ones that got sun grew. So all I'm going to do is take the 35 and multiply by 0.8. That gives me 28. That means 28 grew out of those and 7 did not grow. Okay, you can either multiply by the 20% or just subtract. Now down here we got 65. It said 15% grew. So I do 65 times 0.15 and I get 9.75. That's the percentage that grew. Again, we subtract, we get 55.25. Now I get it. In the real world, we're not going to have a decimal of a plant, but that doesn't matter. We're trying to figure out percent. So then it says, what is the combined? As soon as you see combined, all you're going to do is add. That a plant grew. 28 here grew, 9.75 grew, 28 plus 9.75 is 37.75. The combined probability that they did not grow, either subtract that from 100 or just add those two together, you get 62.25. Now, really quick, here's what's going to happen. Later tonight, I'm going to start checking in your probability packets that are due tomorrow. They're being graded for completion, not accuracy. Once you submit it, okay, in all 12 pages, all right, I will check it off and return to you the solution so you can check them. Tomorrow morning, I will post the last quiz of the year on probability. All right, I think it's 20 questions. It's worth 50 points. All right, and then that will be the last grade. That's 50 points. So you got 40 points in homework for the last week and then 50 for the quiz. And then next week is going to be either makeup work for people who've missed stuff or working on the Algebra 2 summer review packet. We're going to give you sample problems that enable you to work through if you have questions. If you do have questions next week, feel free to ask as you work on the summer packet. Giving you the opportunity to get that out of the way. That's all the work that you're expected to do, okay, once you walk in the doors in September. This year hopefully did not have a negative impact on your algebra skills, okay? The one thing I would say to you about the probability quiz tomorrow and all this work, if there's something you don't understand, make sure you ask, because this is on the PSATs next fall. It is on the SATs when you take that, and it is on the ACTs. And it isn't something that naturally fits into other courses. So you may or may not see it again. Depends on the time in the class and those types of things. Obviously, if you take AP statistics, you're going to see a lot more than if you don't. All right, so I'm going to get to work on grading those hopefully momentarily. Get those back to you, check it in, and once I check it in, I'll send it to you. And the quiz will be up tomorrow, but it's not due until Friday, so make sure you get that done by Friday so you don't have anything over the weekend. Be safe, be kind, and message me with any questions. Take care. Bye.